One of the things that Engels emphasizes is that socialism can only succeed politically and economically if it's based on some sound scientific theory. And this applies not just to our understanding of present society, but also to an understanding of the laws which will govern any future society. And it was this conviction that led Marx to devote so many years of his life to uncovering what he called the laws of motion of capitalism. He wanted to show what the underlying basis was for the class division of society, and on this basis he wanted to show the limitations of reforms that didn't change the fundamental structure of the society. And in all this, the key to his analysis was the labour theory of value, something which had been developed by previous political economists, but which he brought to its final development. A rough outline of my talk is as follows. I will be talking first about what the labour theory of value is, why it's important to understanding exploitation, how it has been attacked both from the standpoint of the subjective theory of value and from the standpoint of what's been called the transformation problem, what the evidence is for the correctness of the labour theory of value. I'll be looking at what the causal mechanisms behind it are, and possibly answering some new objections to it. What does it say then? At its simplest, it says that the average price of a good will be proportional to the average labour used to make it. And if you look at a whole industry, the value added in an industry will be roughly proportional to the labour that the industry uses. Price quantities, therefore, are seen as the indirect representation of underlying quantities of human time. This is the basic insight of the labour theory of value from Adam Smith onwards. The theory was developed by Adam Smith in the late 1700s, further refined by the English economist David Ricardo in the 1800s, and by the 1820s the theory was being used by a number of socialists like Thompson and Gray to argue that since labour was a source of value, profits and rent must be nothing other than exploitation. These critiques were further refined and popularised by a German émigré, Dr. Marx, who was living in London in the 1860s, and it's through his version of it that the theory has come down to the present. It had been almost universally accepted in the early 19th century. The leading economists all believed in it. But by the mid-century it was being criticised in establishment circles because it was seen as politically risky. And then by the late 19th century only socialists still supported it, whereas most orthodox economists had moved to alternative theories from marginalism or subjectivism. And these alternatives remain the orthodoxy that is taught to students in economics to this day. Let's look at some of the lines of attack that conservative economists have used. On the one hand, they've said that prices in the end represent subjective valuations of commodities. On the other hand, when they present a more elaborate theory, they say that where you get a price, it's where you get the intersection between what are termed a supply and a demand curve. Now, in another publication, I go into some detail as to why this doesn't constitute a scientific theory. Basically, it's a matter of Occam's razor, which says you shouldn't multiply entities beyond causes. At any one time, all you can observe is a combination of a certain quantity of goods being sold and their price. And you can observe this different quantities being sold on different days. If you're going to explain that in terms of two curves, you are inventing more unknown entities than there are observables, because a curve, even in its simplest form of a straight line, requires at least two constants to define it. If it's not a straight line but has some degree of curvature, you'll require 3, 4, many constants to define it. These being the parameters of a polynomial. Now, if you have a series of made up or unknown constants, and there are more unknown constants than observables, then you have a theory which is unfalsifiable, because you can always make up combinations of these constants which will explain the observations. So as a basic principle in a scientific theory, you can't have more unknowns in your model than there are data points. And the entire supply and demand model demands that you have more unknowns than data points. So it can explain everything and can never be falsified. The next basis has been to critique the labour theory of value as being inconsistent based on what is called the transformation problem. This at least has the virtue of being in some way tied to what some of the writers on the labour theory of value have themselves said, both Ricardo and Marx. And this has been the basis that was pushed by the orthodox economist Samuelson, a guy whose textbook was the most widely used introductory economics book in the US. Now, any scientific theory has to be one that makes predictions that can be put to observational test. That's something I was saying in the case of supply and demand theory. It's untestable. If it makes no predictions, it's meaningless. And if it cannot be tested, it's not scientific. If it is testable, and if its predictions are borne out by observation, then the theory should be accepted. Now, how does this apply to the labour theory of value? How would we set about testing it? To verify it, you need information on the money value of the output of lots of industries, and you need information on the labour content of the outputs of these industries. If the money value is closely correlated with the labour content, then the predictions of the labour theory of value have been confirmed. If, on the other hand, they were uncorrelated, then the labour theory of value would clearly be falsified. How do you get this information? Well, you couldn't have done it 100 years ago. But you can do it nowadays, since all countries publish what are called input-output tables for their economies. I'm going to show you a sample input-output table, explain how it works, and then I'll explain how the tests have been done. Okay, this is a view of the United Kingdom input-output table. In such a table, you have a set of headings down the left, which say what all the industries are, and these are repeated along the top. And then you have a set of cells within the table, which tell you how much of the outputs of one industry are used in another. So if we take agriculture, forestry and fishing, we can see that agriculture, foresting and fishing was 2,283 million pounds worth of it were used by the agriculture, forestry and fishing industry. Another 6 million pounds worth of the output of agriculture, hunting, forestry and fishing was used in the mining and quarrying industry. If we look along a bit, we can see that food production used about 10 billion pounds worth of output of agriculture. Textiles used 31 billion pounds worth. The wood industry used 21 214 million pounds worth, etc. So if you look on the left hand side here, you have the industries, and as you go across each row, you see how much of that industry's output was used by each of the other industries. And then right down at the bottom, we see how much labour was used in that industry, and then we see what the output of that industry was in money terms. Given the table, and given a computer program that will read it and process it, you can work out how much labour was used directly and indirectly to produce the output of each industry. So if you're trying to work out how much labour was used to produce the output of the mining industry, you include the direct labour used at the bottom of the row, and then you see how much labour was used indirectly in each of the other industries that it used products from. And it doesn't take very long to calculate this. When you've done that, you get figures for the amount of labour that was used by each industry, and you have figures for the actual price for which that industry's output was sold. Now, I have graphed the data from the UK industry there, and I have made available to people a program which will work from such input-output tables to give the results I've used here, so you can test it yourself if you wish. And the thing to notice about this is that the data roughly lies on a straight line, which is what you'd expect. If it's the case that the number of person years determines the value of the output, then you'd expect a complete straight line here. Now the data is very close to a straight line. There is some jiggering and jaggering about, but basically it's a straight line, which is what the labour theory of value predicts. There are just a couple of extreme outliers here, and those turn out to be the oil and oil refining industries, the value whose output is rather higher than you would predict by their labour content. But these are what the classical economists call natural monopolies, and the Ricardian theory of rent says that industries which have natural monopolies and depend on the ownership of land, in the British case the ownership of the seabed, can be expected to sell their output at a price that's above their labour value, or above their average labour value. They're governed by what's termed the marginal labour value. So the results shown here are entirely conformant with what Ricardo's labour theory of value predicted. If we go on to some other countries, we can look at here are the countries, these are the years the studies were done in, this is the number of industries, and this is the degree of correlation between the labour content and the value of industrial output, or sectorial industrial output. And it's extraordinary how strong the correlation is. 98.6% for Japan, 97% for the USA. The UK has somewhat lower results than the other ones. That was the UK data I was giving you, 95.5. So the UK data I gave you was unusually poor. Most countries the correlation is much stronger. It's as close as, damn it, to a straight line.